Hello everyone and welcome to the lecture on Amazon RDS. So Amazon RDS, Managed Database Service. Amazon RDS is a web service that makes it easier to set up, operate and scale a relational database in the cloud. Supports multiple database engines. RDS supports several popular database engines including MySQL, PostgreSQL, MariaDB, Oracle, Microsoft SQL Server. Scalability and performance. With a few clicks, you can scale RDS instances vertically and horizontally to meet application demands. High availability and backup. Offers multiple AZ deployments, automated backups, and database snapshots for durability and data protection. Security and compliance. Provides built-in encryption, VPC, IAM integration, and compliance certifications. Automated maintenance. RDS automates time-consuming tasks such as software patching, backups, and system upgrades. Integration with AWS ecosystem. Seamlessly integrate with other AWS services like Lambda, CloudWatch, and Elastic Beanstalk. Cost efficient and resizable. Pay only for what you use with options to reserve instances and reduce cost. Monitoring and metrics. Integrated with Amazon CloudWatch for monitoring database instances and getting real-time performance metrics. Easy to migrate and operate. With the AWS Database Migration Service, you can easily migrate or replicate existing database to RDS. Engine types in Amazon RDS. Amazon Aurora, a MySQL PostgreSQL compatible relational database built for the cloud. It offers up to 3 times the performance of MySQL and up to 2 times the performance of PostgreSQL. MySQL, one of the world's most popular open source databases, suitable for a wide range of applications. PostgreSQL, an advanced enterprise class open source relational database known for extensibility and SQL compliance. MariaDB, a popular community developed fork of MySQL known for its speed and robustness. Oracle Database, a powerful multi-model database management system by Oracle Corporation, widely used in enterprise applications. Microsoft SQL Server, a relational database by Microsoft with advanced data integration, analysis and reporting solutions. Key terminologies of Amazon RDS. DB instance. A database instance is a standalone database environment, an isolated database environment in the cloud. DB engine. The core software that runs the database, example MySQL, PostgreSQL and others. DB parameter group. A container for database engine configuration values that can be applied to one or more DB instances. DB option group. Represent a collection of engine specific features and their settings for a DB instance. DB snapshot. Represent a collection of engine specific features and their settings for a DB instance. DB snapshot. A user initiated backup of your instance stored in Amazon S3 that can be used to restore data. Then multi-AZ deployment. A high availability option that creates a standby replica of the DB instance in a different availability zone for failover support. Read replica. A read-only copy of the primary DB instance, useful for scaling read operations and offloading traffic from the primary instance. Endpoint. The DNS address used by the applications to connect to a database instance in RDS. Provisioned IOPS, input-output operations per second. It is a feature to optimize and guarantee consistent I/O performance. DB subnet group, a collection of subnets, typically private, that you may want to designate for your RDS DB instances in a VPC. Features of Amazon RDS. Automated backups. RDS automates backups of your database, storing them securely on Amazon S3. Backups can be scheduled and can have retention policies. Multi-AZ deployments. For high availability, RDS provides automatic failover support by maintaining a synchronous standby replica in another availability zone. Read replicas. To enhance read throughput, RDS supports creating one or more replicas of a given database instance. Database engine flexibility. So it supports popular engines which we have already talked about, MySQL, PostgreSQL. Automatic software patching. RDS handles routine software patching automatically, ensuring that the database is up to date with the latest patches. Built-in encryption. RDS offers data encryption at rest and in transit using industry standard encryption techniques. Scalability. RDS instances can be scaled up or down based on requirements, and read replicas can be added for increased read throughput. Monitoring and alerts. Integrated with Amazon CloudWatch, RDS provides real-time metrics and alerts for monitoring database performance, access management and security. Integration with AWS IAM allows for fine-grained control over who can access RDS instances. Integration with AWS services. RDS integrates seamlessly with other AWS services, enhancing data transfer, analytics, security, and more. Settings for creating Amazon RDS. Engine type, which we have already seen. There are 6 total engine types. DB instance class specifies the compute and memory capacity of the RDS instance. Options range from small to memory or compute optimized types. Multi-AZ deployment. This option allows for setting up high availability by replicating the database in different availability zone. Storage type and size. User can choose between general purpose SSD, provisioned IOPS SSD or magnetic storage types and define the storage capacity. Security groups. Define which IP addresses or EC2 instances have permission to connect to the RDS instance. Database name and credentials. Set the initial database name, master username and password. Backup settings. Define automatic backup windows and retention periods. VPC and subnet group. Select the virtual private cloud, VPC and subnet group where the RDS instance should reside. Encryption. Opt to encrypt the database using AWS Key Management Service. Parameter and option groups. These allow for advanced configuration settings and additional features based on the selected engine. Cost pricing of Amazon RDS. Pay-as-you-go pricing. With RDS, you pay only for what you use with no minimum commitments or upfront cost. Reserved instances offers cost savings for RDS if you can commit to 1 or 3 year term. It comes in 3 offerings: all upfront, partial upfront, and no upfront. Database storage and I/O operations. Charges are based on the amount of storage provisioned and the number of I/O operations performed. Data transfer cost. Generally, data transfer into RDS is free, but data transferred out of RDS to the internet or other AWS regions may incur cost. Backup storage cost. While automated backups of up to 100% of your provisioned storage are free, you might be charged for additional backup storage. License model options. For Oracle and SQL Server, there are options like license included or bring your own license, which might influence the cost. Snapshots export charges. Exporting DB snapshots to Amazon S3 incurs a fees. Regional variations. Pricing may vary depending on the AWS region in which the RDS instance is launched. RDS proxy pricing. If using RDS proxy for database connections, there are additional charges based on hours of proxy running and the amount of data processed. Performance aspects of Amazon RDS. Provisioned IOPS. Designed for IO intensive workloads, it provides consistent and high input-output performance. SSD storage. General purpose SSD storage, a balanced storage solution that offers a blend of performance and cost effectiveness for a variety of transactional workloads. Database engine optimization. RDS is tailored for specific database engine in use, ensuring each engine's peak performance. Multi-AZ deployments. Enhances database availability and performance by maintaining a synchronous standby replica in another availability zone. Read replicas. Helps offload read traffic from primary database, enhancing read operation performance. Enhanced monitoring tools. Provides granular real-time metrics about RDS DB instances, aiding in performance diagnostics. Performance insights, an advanced performance monitoring feature that helps in identifying and analyzing database performance bottlenecks. RDS proxy reduces database load by pooling and reusing database connections, enhancing overall application performance. Query analysis and optimization. The RDS console offers tools to analyze SQL queries, helping users optimize for better performance. Bustable performance instances, ideal for workloads with varying compute needs. It provides base performance with the ability to burst to higher performance. Security features of Amazon RDS. Data encryption. At rest and in transit. RDS uses AWS KMS for encryption at rest and SSL TLS protocols for data in transit, safeguarding data from breaches. IAM integration for access control, leverage AWS identity and access management for user authentication and role-based permission, reducing password management complexities. Deployment in virtual private cloud, launch RDS instances in a VPC, offering private isolated section of the AWS cloud for enhanced security. network isolation with security groups, act as a virtual firewall, controlling the inbound and outbound traffic, ensuring only legitimate access, key management with AWS KMS, manage cryptographic keys seamlessly with AWS Key Management Service, providing centralized control, secure connection using SSL TLS, and enforces encrypted connections between the application and RDS instances using SSL TLS, ensuring data privacy, multi-AZ data redundancy, ensures data resilience by maintaining a synchronized replica in a separate availability zone, encrypted backups and snapshots. All automated backups, manual snapshots, and database logs are encrypted, ensuring data security at all points. Database activity streams and audit logs, monitor and log database activities in real time, offering insights into SQL statements executed and ensuring traceability. Compliance with industry standards, adherence to multiple compliance certifications like HIPAA, GDPR, and others, meeting global security standards. Logging and monitoring options in Amazon RDS. Amazon CloudWatch Matrix provides metrics related to DB instance CPU, memory, storage, and I/O operations. Amazon CloudWatch alarms enable setting up alerts for specific thresholds on monitored metrics. RDS Performance Insights, an advanced performance diagnostic tool offering insight into database load. Enhanced monitoring delivers OS level metrics with high granularity, offering an in-depth view of DB instance performance. Database event subscription allows users to receive notifications about specific RDS events through Amazon Simple Notification Service. RDS Console Query Analysis provides insight into SQL queries being executed, aiding in performance optimization. RDS Database Log Files supports various logs like error logs, query logs, etc. User can view or download these logs for detailed analysis. AWS CloudTrail integration tracks all API calls, helping monitor and review action taken in the RDS environment. Automated diagnostic reports. Some RDS engines like SQL Server offer diagnostics that generate performance and health reports. DB snapshot and restore monitoring allows tracking of snapshot related operations, ensuring visibility into backup and restoration process. Best practices for Amazon RDS. Multi-AZ deployments. Always use multi-AZ deployments for production databases to ensure high availability and failover support. Regular backups and snapshots. Enable automated backups and regularly take manual snapshots to ensure data durability and to facilitate disaster recovery. Monitor with CloudWatch. Keep a close eye on RDS metrics using Amazon CloudWatch to identify and rectify potential issues promptly. Optimize queries and indexes. Regularly review and optimize your database query and ensure that your database tables are well indexed. Use encryption. Implement encryption at rest and in transit to safeguard sensitive data. Manage access with IAM. Utilize AWS Identity and Access Management to grant specific permission and ensure secure access to the RDS instances. Scale resources as needed. Proactively adjust instance types or storage based on demand, ensuring optimal performance without over-provisioning. Set up read replicas. For read-heavy databases, set up read replicas to distribute read operations and reduce the load on primary database. Opt for provisioned IOPS. For input-output intensive workloads, consider using provisioned IOPS storage to achieve fast, consistent performance. Secure in a VPC. Always deploy RDS instances in a virtual private cloud for enhanced security and network controls. Integration with Amazon RDS, AWS IAM. Manage access to RDS resources by defining permission and roles. Amazon CloudWatch. Monitor RDS performance metrics, set alarms and access logs for analysis. AWS KMS. Encrypt data at rest in RDS, ensuring secure management of cryptographic keys. Amazon VPC. Deploy RDS in a isolated network environment for enhanced security. AWS Lambda. Trigger serverless function based on RDS events or changes, allowing for event-driven architectures. AWS CloudTrail. Log and monitor RDS API calls. Amazon SNS. Receive notification for RDS events such as backup, updates, or failovers. AWS Elastic Load Balancing. Distribute incoming traffic across multiple targets, ensuring high availability and fault tolerance for application using RDS. Amazon Route 53, direct domain traffic to RDS endpoints or manage domain names for RDS instances. AWS DMS, AWS Data Migration Service, migrate data to and from RDS from various sources, making database migration smoother and more efficient. RDS integration with AWS analytical tools. QuickSight data visualization. Amazon QuickSight can directly connect to Amazon RDS databases, allowing users to visualize, analyze, and generate insights from their relational data. EMR cluster analysis. Amazon EMR Elastic MapReduce can access RDS databases for analytics. User can run big data frameworks like Apache Spark or Hive on data stored in RDS. Athena SQL queries. Amazon Athena can run ad hoc SQL queries on data exported from RDS to S3, providing a serverless query capability. Data source configuration. These analytical tools offer simple configuration to set RDS as a data source, often through a point-and-click interface. Direct database connection. Tools like QuickSight come with built-in connectors for RDS, enabling direct and real-time querying of database data. Federated queries with Athena. Athena supports federated queries, allowing users to run SQL statements across data stored in RDS and other sources. RDS as a data sink in EMR. EMR clusters can process vast amounts of data and then store processed results back into an RDS database for further analytics or reporting. JDBC ODBC drivers. Integration between RDS and these tools is often facilitated by JDBC or ODBC drivers. Secure data access. Integration adhere to AWS security best practices using features like VPC peering, IAM roles, and encrypted connections. Optimized query performance. Integration points are optimized for performance, ensuring that analytical queries can run efficiently and effectively on RDS data. High availability in Amazon RDS. Multi-AZ deployments. So RDS allows for provisioning of standby replica in a different availability zone. Read replicas. Create one or more replicas of a given DB instance to offload read traffic, increasing system availability. Automatic failover. In the event of DB instance failure, RDS automatically routes traffic to a standby in another AZ. Data replication. Synchronous replication between primary and standby instances ensure data consistency and availability. So built on reliable infrastructure. Standby replicas. These are automatically created and maintained in a separate availability zone for disaster recovery and high availability. Backup and restore mechanisms. Automated backups, manual DB snapshot, and point-in-time recovery snapshots. Health checks. RDS continuously monitors DB instances and automatically replaces failed instances. Redundant systems. Hardware, network, infrastructure, and storage redundancy maximizes availability. Continuous monitoring. Using Amazon CloudWatch, RDS is monitored 24/7. Fault tolerance and reliability in Amazon RDS. Resilient infrastructure. AWS infrastructure underlying RDS is designed for durability and resilience. Redundant data storage. RDS automatically replicates data across multiple storage blocks in multi-AZ deployment. Automated backups. So RDS takes daily backup of DB instances. System snapshots. Manual snapshots can be taken anytime, offering another layer of data preservation. Protection from DB failures. Automatic failover capabilities mean that in the event of a database failure, traffic is rerouted to a standby replica. Self-healing storage. RDS storage automatically repairs detected issues, ensuring data reliability. Diverse availability zones. Spreading resources across multiple AZs shield against failures of a single location. Disaster recovery protocols. Procedures are in place to recover from natural or human-induced disasters swiftly. Isolated network (VPC). Using Amazon VPC, databases can be isolated, reducing threats and improving reliability. Regular maintenance and patches. RDS ensures that database engine stays up to date, secure, and reliable. Some quotas and constraints for Amazon RDS. DB instance limit. Typically, AWS accounts are limited to 40 RDS DB instances per region, but this can vary based on the account type. Storage capacity. Depending on the DB engine, the maximum storage capacity varies. For MySQL, MariaDB, and PostgreSQL, the limit is 64 terabyte, and limits for Oracle and SQL Server might vary based on additions. IOPS range. With provisioned IOPS SSD storage, the range is from 1000 IOPS all the way up to 80,000 IOPS, depending on DB instance type and size. DB snapshot. The quota is usually set at 100 manual DB snapshots per region, but it does not include automated snapshots, so it's only manual DB snapshots. Parameter group limit. An account can create up to 20,000 custom parameter groups per supported engine. Subnet group limit. Typically, an AWS account is limited to 100 DB subnet groups per region. Endpoint connection limit. Connection limits vary based on the DB instance class, with a range usually from 150 to several thousands of concurrent connections. Security groups per DB instance. Each RDS DB instance can usually be associated with up to 5 VPC security groups. Read replica per DB instance. The default limit is 5 read replica for each primary DB instance, but it can vary by DB engine. Max DB identifier length. For most engines, the maximum length of a database engine is 63 characters, but this might vary depending on the specific database type. Okay, two more important features: cross-region automated backups in Amazon RDS. So, cross-region automated backups refer to the capability to store automated backups of an RDS database in a different AWS region from where the primary database resides. Data durability. Storing backups in multiple regions ensures high data durability and reduces the risk of data loss. Disaster recovery. In case of a regional outage or disaster, backups in another region can be used to restore services quickly. Backup retention. AWS allows users to specify retention period for automated backups, determining how long they are stored. Restoration process. Cross-region backups can be restored in the same alternate region, facilitating quick recovery. Encryption. RDS ensures that backups are encrypted at rest using AWS key management service for security. Cost implications. Storing backups in another region comes with additional charges, including storage cost and data transfer fees. Storage type. Backups will use the same storage type as the original RDS instance, be it general purpose SSD, provisioned IOPS SSD, or magnetic. Limitations. There may be restrictions on frequency of backups, their size, or the region they can be transferred to. Monitoring and alerts. AWS provides tools and notifications to monitor the status of backups and alert users of any issues. Cross-region read replica in Amazon RDS. Cross-region read replicas allow you to have read-only replica of your RDS instance in a different AWS region from the primary. Supported DB engines. As of the last update, RDS supports cross-region replica for MySQL, PostgreSQL, and Amazon Aurora. Latency reduction. Serving read queries from replicas in a region closer to the end users can significantly reduce latency. Disaster recovery. In case of a regional disaster, having a replica in another region can serve as a backup and ensure data availability. Data locality. For multinational operations, replicas can be created closer to where the data processing occurs, improving performance. Migration tool. Cross-region replicas can be promoted to become standalone DB instances, aiding in regional database migration. Consistency. While replication is asynchronous, AWS ensures that replicas are consistent with primary database over time. Monitoring and management. Amazon RDS provides tools and metrics through CloudWatch to monitor the replication lag between primary and its replicas. Cost implications. Creating replicas in another region incurs additional cost, including data transfer and instance charges. Limitations. There is a limit to the number of cross-region read replicas you can have, and not all DB engine features or version might support this. And that's all. Thanks for watching.